Number one, drag. Drag, correct answer is C, a friction-like force that affects an object moving through a liquid. A liquid, in this case, as stated in your text, is a gas or an actual liquid. Number two, inertia. Inertia is the resistance of an object to a change in motion. Number three is B. Friction is a force that opposes motion between two surfaces that are in contact with one another. Question number four under key concepts. Describe what is the action force and the reaction force when you sit down on a chair? The answer, the action force is your body pressing down on the chair, and the reaction force is the chair pressing up. On page 418, our text supports this with right here. We see here it says weight is pushing down is the action. The reaction force is the chair pushing on your body. Number five, use the concept of fields to describe how forces can act from a distance. Some objects create a field around them. Objects in that field feel the effect as a distance force. So on page 410, here we see the three different types of fields. We have electric fields, which you may have seen with static electricity, getting a little kid's hair to stand up at a birthday party by rubbing a balloon on their head, right? Magnetic fields and gravitational fields. So these fields all act from a distance, or we would also call them a non-contact force. Number six, summarize. How do you determine net force? Well, you add the forces that act in the same direction. You subtract the smaller force from the larger when the forces act in opposite directions. We see this on page 412. So we add when they're in the same direction. We subtract when they're in opposite directions. Here's an example. The guy pushing the box, 210 newtons. The box pushing back with 190 newtons. We subtract, our net force is 20 newtons. Number seven, how do tests with crash dummies, seat belts, and airbags illustrate Newton's first law of motion? Well, the answer states, after the car stops, the dummy inside keeps going because of inertia until the seat belt and airbag exert contact forces on the dummy. On page 414, we see Newton's first law. It says, tendency of all objects to resist changes in motion. So the car's going until it hits a wall, and then the dummy is going until he flies forward and either hits the airbag or the seat belt. Question number 8. This rock, known as Balance Rock, sits on a thin spike of rock in a canyon in Idaho. Explain the forces that keep the rock balanced on its tiny pedestal. Well, Balance Rock does not move because of inertia. The forces are balanced. The force pressing down on the spike and the force pressing up on the spike have a net force of 0. On page 413, we see right here at the top, balanced forces will not cause change in motion of a moving object or a non-moving object to start moving. Calculate. Balanced rock has a mass of about 36,000 kilograms. If the acceleration due to gravity is 9.8 meters per second, what is the force that the rock is exerting on its pedestal? Well, we see force is equal to mass times acceleration. So the mass is 36,000 kilograms. Acceleration would be 9.8 meters per second. We get this when we multiply them together. 352,800 kilograms. times meters per second, or 352,800 newtons. So if we look back on page 416, we see right here, 1 Newton is equal to 1 kilogram times meter per second. So therefore, that's where we get our two. Number 10, infer. What would happen if the moon happened to the moon if Earth stopped exerting a force of gravity on it? Well, the moon would stay in orbit around the Earth because of Earth's gravity. If Earth no longer exerts a force on the moon, then the moon would travel in a straight line away from Earth. Newton's first law on page 414 would help illustrate that. An object at rest tends to stay at rest, or an object in motion tends to stay in motion at the same speed and direction unless it experiences an unbalanced force. You could illustrate this by tying a spherical object or a ball to a string and twirl it around above your head. The ball is going in a circle around and around and around. Once you release the string, you let go, the ball flies off in a direction in a straight line. Hey, thanks again, guys, and we'll see you again next week.